here we have Earth in cross section. Please note, if you cut the Earth in half to get a cross section, it will immediately collapse. Don't do that. Okay? Also, the energy to do this would be a super cool exercise to calculate. Yeah. What is the minimum amount of energy required to cut the Earth in half would be a very cool question. An even better question would be, what is the amount of energy required to cut the Earth in half and then keep the halves separate?
Oh.
That's a much larger question.
Because gravity would suck them back together.
Yeah, of course, because they'll attract each other immediately. So you'll have to spin it up really fast to get them to separate a little bit.
It'll be fun to notice that like it'll take more energy to push whatever blade you're using down past the center because gravity's going to pull it back up.
Yeah, and of course you get some kind of weirdness as you use this knife. I would recommend using. No, it's all outside. This is like basically not possible with the amount of energy we have in society. If you took the entire sun's output, you could probably do this, but that's the order of magnitude we're talking about at least. All right, so anyway, point is, Earth. This is the center of the Earth, where there are dinosaurs or lizard people or something. And then up here at the top, we have a ship, which looks like this, I think. And then we have a crow's nest at the top of the ship. Right? You guys know what a crow's nest is?
Yes.
Okay. Sorry, I have to ask sometimes. All right. And then there's some kind of length along the surface of the Earth that we can see. And what's this point, the furthest you can see?
The horizon.
Cool. That's the horizon here. This is some kind of L distance they're telling me. This is the furthest you can see. Crap. So this is the furthest you can see from the top, and so we're going to call that D. That's the distance to the horizon as seen from the crow's nest, right? Okay. Let's see. So you're perched in a crow's nest C on top of a mast of a ship, C figure. You will calculate how far you can see when you're X meters above the surface of the ocean. Okay, so I'm going to dump most of my ship here because I need labels. So that's X tall. Note the ship is now sinking quickly. Okay, so I need to find the formulas for D, the distance I can see to the horizon, and L, the distance to the horizon along the Earth's surface in terms of X, the height of the ship's mast, right? So that's this guy. And R, the radius of the Earth. Why is that coming in handy? Where is that?
Because you need to use, what is it called?
Something about an arc length?
So what's it called?
Yeah, the formula to find the length.
Okay. Okay, so there's radii, right, of the Earth. One's from the center to the ship, the other one's from the center to the horizon. And then they put an angle theta in here, right? Okay, so thoughts? What do I need to do?
Do they give you any numbers? Or
Yeah, they don't give me any numbers at all. They want me to find, what did they want me to find? They want me to find,
L, right?
L is R theta.
find formulas for D, the distance I can see to the horizon, and L, the distance to the horizon along the surface in terms of X and R.
So they want X to be 1?
No,
L
L
is
is
R
R
theta.
theta.
To find L.
Okay, so they're saying you know R and X, find D and L in terms of R and X. You guys see that? Okay, so let me take my best crack. Which one of these is easy from the picture? Yeah, L-ish, right?
Yeah.
So L is what?
D squared minus X squared? Or
R
L
theta.
squared is D squared.
Oh, sorry. Hang on. this thing L, right? Is that flat?
There you go, okay.
Thank you.
Yeah.
I was,
Sorry,
I thought there
L
was
is
a flat
the
line and an arc.
surface
I was like,
of
what
the
hell?
Earth, so it's curved. Because again, it's round, for real, despite with doubly the height.
It's R theta.
Okay, so L is R theta.
Not your theta, it's R theta.
Okay, so L is R theta. What else?
I thought the R was square.
Thought the R was square.
In the in the arc length?
Yeah, so this is arc length is the radius times the angle. There's an R squared in the one for areas of sectors, but I'm doing arc length. Cool? Yes? All right. How do I get D out of this? Oh, it's gonna be weirder, right?
Oh, Rob's, no, Rob's not.
Ooh. That's a cool idea.
You also do Pythagorean, right?
No,
it's
not right
X
there.
minus R, or R
Yeah,
minus-
so I'm leery of the Pythagorean anything here. Why?
It's not a right
You don't
triangle.
have values. You have a right triangle.
No, I can't do
No,
that.
because it's an angle.
According to this picture, you do.
Ooh.
Wait, really?
So why does Ethan think I have a right triangle, and why is he right?
Because the angle might be 90 degrees, but the relationship between that 90 degrees and the length of D is not going to be the same because that 90 degrees would be.
Wait, which
corresponding to our
which
right.
angle is right?
So,
That's my
H-
question.
H is the 90, and you go CHR or whatever it is.
So-
It's 90.
Why is that a right angle? Why is the angle between the line to the horizon and the
Because it's a
radius?
tangent line and it intersecting a radius?
Yeah. This is a tangent line, right?
Oh, okay.
So it's lying tangent to the circle, and that means it's perpendicular to a radius that ends there. That's actually relatively tough to show, but I think is pretty easy to observe. You guys see that?
Yeah.
Yeah.
I was talking about the 90 degrees between X and L.
Between X and
Yeah,
L.
that's what I was thinking.
Yeah, so
That would not.
that's a much weirder 90 degrees.
Yeah.
That's also true,
Well,
Right.
what I was saying.
because the
was,
ship sticks straight out of the world,
Uh-huh.
but L's not even a side of a triangle, right? It's
Yeah,
bent.
that's what I was saying. So even if.
So
it
I
was
don't even
90
know what an
degrees, it
angle
wouldn't
to
make
that thing means yet.
Yeah.
What you're talking about there is the angle of a tangent line meeting that vertical.
Yeah.
You guys see that?
That would be.
So yeah, this is totally also a right angle, but it's a right angle to a curved thing, so I have trouble with that. All right, so I think I got L is R theta, and what else?
Sine of D over R plus X.
Sine of D over R plus X.
Well, I mean, sine of theta is equal to D over R plus X.
Okay, I like that better.
Yeah.
D over R plus X. So that's looking at theta, right? And saying, okay, the opposite side is D, and the hypotenuse is X plus R long. Perfect.
You just solve for D and that's your answer, right? Because that's in terms of R and X.
Oh, but I've got thetas in both my things here.
Oh,
You
yeah,
guys
but you
see
need
that?
only R's and X?
Yeah, they want
Okay.
only R's and X's. So how the heck do I get a theta out of this thing? What do you know about
Sine
theta
of-
here?
It's less than 90 degrees.
Okay, good. It's probably in the first quadrant because the Earth is really big, right?
Yeah.
Also, it would be weird if you could see more than 90 degrees around this thing, because it's supposed to be a frickin' circle.
That'd be cool though.
That would be super cool. I am not clear that you can ever do that, regardless of the relative scales. I believe you can't.
What about an astronaut?
So I
No,
think
as
if
high as you go, you'll
I think
still-
if you're standing on a marble,
Uh-huh.
well, one, you can't see it because it's under your shoe. But for another thing, I think your vision goes like this, right?
Yeah.
So I
you
think
can
the
see
best you're
everything.
going to be able to do is see that 90-degree segment there. I don't think you'll be able to see any of the underside of the marble because you're standing on top of it.
Well, no, if an astronaut goes out into space and he's looking at the Earth, he can
No.
see a full circle, right?
Yeah.
Oh yeah, when you look down, you'll be able to see the whole top half.
Yeah, so you'll be able to see
The whole top half,
180.
But only the whole top half.
Yeah, just that one half. Yeah.
So this angle, right, between the middle and one of the horizons can't ever be bigger than 90 degrees. Yeah. Pretty sure.
X-ray vision
Yeah.
on a global scale.
Unless there's mirrors. If there's mirrors, you're totally screwed. Okay, so I think I should be able to get theta somewhere. How do I get theta? We've been wandering forever.
To inverse sign.
Oh,
Or you could divide by R on the top one.
or I could divide by r on the top one. Yeah, that would totally work. That's probably the easy one, right? Say, okay, theta is L over R, right? Yeah. Take that, cram that in here.
Wow.
Get sine of L over R is D over R plus X. Is that what they actually wanted?
No.
Oh
We
no,
still have an L.
that's hilarious, but not what they wanted. So why is this not what they asked for?
Because they want it in terms of X.
Yeah, they wanted me to find a formula for D and L, which means they wanted a formula for D and also a formula for L. And what I have here is one tangled mess of formula that relates D and L. You guys see that?
Yeah, that's awful.
Okay, so let me back out of that a little bit. So this is cool,
But not
maybe
helpful.
not useful. Okay, so what do I do instead?
Keep them separate.
Keep them separate. Okay, so I want to find theta somewhere, right? So what do you know about theta?
It equals L over R.
It equals L over R. Yeah, okay.
What's this
How
one
did we
back
get it
over
in
here?
terms of?
Yeah. I want to be able to get this thing in terms of D's and R's and X's, right?
Then, yeah, you would use arc sine, or inverse sine.
Yeah, so we could use arc sine to find theta, right?
Yeah.
That's not going to help me on this one in particular.
Yeah, but you said you need in terms of D's, R's, and X's. And that
Yeah,
would-
that's going to get me theta in terms of D's, R's, and
Yeah.
X's, right? I want another, like, I want a tool that I can use to find theta, and I know all of the sides of a triangle. What's that?
You can use tangent to relate R, X, and D.
Oh, that's another option, right? You guys see why I want kind of a different trig function here? Right? So, what do I know about tangent of theta?
Tangent of theta equals D over R plus X.
Tangent of theta works how now?
Opposite over.
Opposite over adjacent. So it's
Oh, that's
R
Oh,
over
D over R.
over R.
I think I got D over R, right? You're standing here,
Okay,
opposite sides D,
yeah.
the adjacent sides R. So theta should be the
Arc tangent of D
arc
over R.
tangent of D over R. And I'm not worried about having cut arc, no.
Suppose you can only-
Sorry, Adam's shaking his head over here and making me nervous. So, arctangent of D over R, then what?
Celebrate.
Celebrate, yes! Yeah, you can totally celebrate at this point, but you all don't know why. So what was my point? My point was to find theta, right? So that I could shove that back in over there. Right? So I'm going to take my knowledge about theta and I'm going to trot it over here and I'm going to plug it in right there and right there. So ultimately here I have theta. Theta is the arctangent of d over r. Oh shit, this still has d's in it. Why'd you guys let me do this?
No, I said this all.
Yeah, well, I was wrong. Shit. Okay, so how do I get the d out of it? I didn't want tangent.
The only other one is cosine.
Yeah.
Yeah,
It's
that,
R's and X's.
right? I know about sine, which I already used. Tangent has frickin' d's in it. This is useless.
Yeah, remember when I suggested it was r over r plus x? I was thinking cosine but said tangent.
Yeah, that's a much better idea. So I think cosine of theta is what?
That would be r over r plus x.
Yeah, right, the adjacent over the hypotenuse. So that's r over r plus x.
Yay, no d.
No d's in it at all, right? This is totally known quantity. So theta is cosine inverse of r over r plus x. Trot this over there and plug it in. That will be much better. So I'll have theta, right? Cosine inverse of r over r plus x is what in terms of L? L over r, right?
Mhm.
So let me just say this. So let me say L is r theta, right? And now I have a formula for L in terms of r's and x's and nothing else. Finally. So that's one of the two things they asked for. Where's the other one? What's D?
Oh, D.
Sine of cosine of something.
Oh, let's see. So I don't quite have D. I have D over R plus X, right?
Yeah.
Is,
Sine theta.
yeah, let's see, is sine of cosine inverse of R over R plus X.
Is
And that should work because that's only going to give you the first quadrant anyway, right?
Yeah, and this will work fine.
Yeah, because then you can multiply it and what they have.
Yeah, so you can multiply D over. So you get D is R plus X times sine of cosine inverse of R over R plus X. And at this point, counting parentheses, at this point I'm thinking I probably should have used the Pythagorean theorem a long time ago. You guys see that?
Almost.
So why do I think I wanted to use the Pythagorean theorem? Because this thing here, right? How do you solve these? You remember? You go right down the angle theta in a triangle, which I already have. And then you just solve for the sides and calculate the ratios. Really, I could notice that, maybe or, D is this side, right? One of the A or B of a right triangle.
Yeah.
So I could take the hypotenuse, square it, and subtract the other side. You guys see that?
Yeah.
This is the exact same thing you'll get out of that, but it'll just take you a while longer. Cool?
now we can celebrate.
That looks a little more reasonable the second answer.
Yeah, and so now we can celebrate, right? So I have formulas. And then part B, oh God. How far is the horizon from the top of a 50-meter mast? How far measured along the Earth's surface is, okay, boring, plug stuff in.
Yeah.
Okay, part B is boring. Sorry.
Well, that was
I'm
fun
not
for
doing
you.
that. Yeah, that was super fun. Questions, complaints? So I think maybe the better approach, right? I'm going to have done this piece at least. right? That cosine inverse had to happen to solve for theta. But this whole business about sines and cosines chasing that d around really should have just been from the Pythagorean theorem at the beginning there. Once I noticed that was right angle, we should have said, oh, I know what d is. Got it. Cool?
Okay.
Questions, thanks? It might have been helpful, and the next time I do an example like this, I'll have to change the colors for things I know to something. That might highlight the difference, and then I wouldn't chase myself around diagrams in circles.